In this video, we are going to do cluster analysis. And this type of analysis is really useful for market segmenting. And in this R script, this is a practice version where I prepare some blanks for you to replace with appropriate functions, objects, or parameters. And please try to reason through each step of the script to understand what it is doing. I will demonstrate how to use it. All right, the first step we need to do is to install all the package required to do cluster analysis. In particular, we need four packages: read Excel tidyverse cluster and open XLSX. Could you please just run the first code? And you will see the R is trying to install the first package. And please do the same for the next code. All right, the function install.package is trying to install the package, but we need to tell R to call the package to use. Okay, so right here we have some blanks. What do you think we should fill in right here? So we should call all the four packages we just installed. The first one is read XL. Then we just type read XL. Okay. The next one will be the tidyverse. We will do the same. And cluster already there. The last package we need to call to use is the OpenXLSX. All right, it's time for us to run the code. Let the library call the first package read XL. The next one, the next one, and the last one. Okay, so right now in our environment, we already have all the required package to perform cluster analysis. The first stage, we need to have the data and prepare the data a little bit. So the next step, we try to read the data file. In particular, the data file was provided in Excel version, and we try to use the function read Excel and store all the data in a variable called dent mass. Okay, so please run the code. And what do you see? You see that it's tried to open a new window for you to choose the data file. In particular, in my case, the data file in this desktop folder and to choose it. Okay, right? And after you choose the data file, in the environment you see the data file name dent mass with 2,300 observation, which is very big, market-based, and with 19 variables, right? Now, the next code is view in the blank. What do you think? What did you name the data set? So basically, we already named the data set as dent max, right? So we just replace the name. And then we run the code and we can see, we can view the data with 2,300 observation and 19 columns. Right. That is how we choose the data set. Now let's explore just a little bit. The first function we can use is names. Basically, this function will help us to show all the column names of the data set. Could you please let me know or try yourself what objects we should fill in here? What we want to see the names of the columns. So basically, we want to see the names of the columns of the object, then maps, right? Then just write the names. And please run the code. Right here, you will see all the column names. ID, time, time two, time total. by best. If you want to know the column name means, you need to check the data description, which is already provided to you. The next function we use is summary. So this function will help us to display some basic summary statistics like mean, max, etc. for each variable, right? And the same, right? We need to fill in the name of the variable that stored the data set, which is max. And please run the code. So right here, you will see the summary for each variable with the mean, median, mean, and max value, etc. Another function that can help you to explore the data in the first hand, that is structure. And right here, what do you think we should fill in this blank? So we need to see the structure of all the data set that we store in this variable, right? So we can key in the Denmark's data set and we can run it. All right, right here we can see the name of different columns, and for each column we can see the values. There's one thing we can see if we opened the data 5. So we can see we have the first column is ID. It's a little bit messy, so you might want to remove this column because, you know, in our studio we already have the ID itself, so we don't need this column, so we can remove it. And to remove it, we can remove the first column right here. So basically, in this blank, you can type 1, represent for the first column of the data set, and the minus sign is removing, okay? And please run the code. And to check if we already successfully remove the ID column or not, we can check the names of the columns of the new data set called DF. So basically right here, we should type DF. Look, now the first column is not ID, it is time. If we can trace back to the previous data set, the first column is ID, so we already remove the first column, right? And for the data set provided, because the company collected data using different scales. For some variables, they use survey item from 1 to 7 Likert scale. For some variables, they use yes, no. For some variables, they used basically just the number of the years, the number of the minutes, etc. So we need to standardize, you know, all the data to have a mean of 0 and standard deviation of 1 to make sure that the programming language will understand all the same way for the following analysis. So right here, you need to think of what data should be scaled. So basically, this is the data we need to scale, right? The DF, the data after we remove the ID column. So we just type DF. And we use the scale function to standardize all the data and store it in the new variable called dfz. And please run the code again. All right. And if you want to get the new standardized data, you can use the view function and put the new variable store the scale data dfz. And please run the code. Okay. The standardized data will look like this. Good. So we just finished the initial data exploration step. We can move on to the segmentation step. First, before we can run the clustering algorithm, we need to compute the pairwise distance between the rows of a dataset using Euclidean distance. Okay? In particular, we need to use this function. And if you have no idea what that function is about, we always can put question mark before the function and run the code. So immediately R will show you the formula how to use that function, right? So right here, you don't need to worry about the other parameters. Let's insert the key parameters for this function. So in the first place, the object we need to key in, that is the data set, right? Itself after we standardized. So the data set after we standardized, we call df set. So let's call it df set. And the method, of course, we are calculating ULID. So just type the name, but make sure that you type correctly as is mentioned in the documentations. You always can check documentations. You don't need to remember how you use the function. You always can check the documentations. And right here, you can type ULID. All right. And let's run it. Great. After you already have the Euclidean distance already, you can start to prepare the cluster diagram. Okay, and to do that, we need to perform the hierarchical clustering. We need to use the functions hclust. And if you have no idea what that function is about, you again can put the question mark in front of the function and see, or will tell you how you could use the function. All right, so right here, I create a new variable called hc.w, represent for hierarchical clustering using the Wadi linkage. Okay, so for this function, the first object we need to key in is the distance. And remember, we just computed the distance above. So we should put that variable here. All right. And the method, as I mentioned, we have several, linkage methods. But in this case, let's use the wordy linkage method. All right. If you are not sure how to type correctly, you need to check the documentations again. Right, let's run it. All right, we just performed the hierarchical clustering analysis. Now let's see how the dendrogram look like. We can use the plot function and we plot the clustering result we just computed above, which is this one. All right. And in the main, we will specify the name of the plot we would like it to be, and X label. What is the label for the XYZ? Remember, for the dendrogram. So on the XYZ, basically, we need to show all the data points and in particular customer, right? Right here, let's call it observation. All right. And on the dendrogram, what is the Y label? The Y label is about the height. This is about the differences, right? Between the clusters. Good. Now let's run the code. Okay. So right here, you will see the X label is observation, and you see the Y label is height. And the name of the plot is cluster dendrogram. You can see here, you can zoom in the plot, right? Okay. So you can imagine because we have like 2,300 observation, that's quite a lot of customer here. So we see a lot of black color here. So it's normal, okay? All right. Let's go back to the R script and run the next code. So after we have the cluster dendrogram, remember I mentioned to you that to choose the optimal number of cluster, you need to use your domain knowledge. You need to use your experience as a marketing managers. There's some method that we can use as a starting point to decide the optimal number of cluster. For instance, the elbow method. Okay, and the code here will show you how to show the height from the clustering result and sort them in the decreasing order. This code will prepare a vector from 1 to 10. Let's run it. And then I try to extract the height, the dissimilarities between the cluster from the clustering result. So right here, I will type height. And remember, hc.w is the clustering result we just computed above. Okay, and let's run the code. We already have all the height from the clustering result. It's time for us to sort it from cluster 1 to cluster 10. Okay. And let's plot the elbow. So it's very similar how you plot the then program. Okay. You also need the plot title. Let's call it the elbow plot. And on the X label, on the X axis, the elbow plot, that is the number of cluster, right? And on the Y axis, we have the within cluster variance. Okay. So let's run the code. And let's color the line a little bit so to make it a little bit more beautiful. Okay. So right here, if you look at this plot, what do you think? Could you please read this line I prepared for you? After how many cluster and when you add more cluster isn't significantly improving the fit within the cluster, you can see this is the apple point, right? After 4 cluster, the variant is blend within the merging cluster is not that significant. So it's very parallel to the x-axis. Okay, so we can see the optimal number of cluster here in this case is 4, right? So you can type 4 here and 4 here, right? All right. Now, we already knew that the optimal number of cluster is 4. So let's try to show those 4 cluster on the dendrogram. Okay, we can plot the dendrogram again with 4 cluster. Let's run this code. Okay, remember the plot, a lot of black here. And this time we already know the number of the optimal number of cluster, which is 4. And we run it. See, now we can cut the cluster dendrogram into 4 cluster, which is optimal. All right, so we just visually see how the cluster are assigned or how, many segments in the market, but we need some specific data from those cluster. That's why we need to move on to the next step. We need to assign each observation to a cluster. In particular, we can use the function cut tree. Okay, we can cut the clustering result into 4 cluster. right? And store it in the cluster variable. Good. Now, it's time for us to know what is the size of each cluster or of each segment, okay? We can use table cluster, okay, right here. So you can see we have 4 cluster. Cluster 1, 1,127 observation. Cluster 2, 506 observation. Cluster 3, 276 observation. Cluster 4, 391 observations. Okay. So it seems like the first cluster is quite huge. Now, to continue, we need to combine the cluster data with the original data using cby function, column combine, okay? So we can combine original data and cluster. So what do you think we should fill in here? So I already have cluster here. So basically this should be the original data, right? And what is the original data? Do you still remember what variable store our original data? Okay. Is it DFZ? No, this is the standardized data. We don't need it because we need to interpret the data. We need the more original one. Is it Denmark's or is it DF? Denmark's have 19 variable, DF have 18 variable. Remember, we want DF because we don't want the messy ID columns, okay? So let's tell the program that let's combine DF and cluster data together and store it in a new variable called DF final. Could you please run the code? Great. And then let's view the DF final. Okay, you can scroll to the very right. And at the end of this data frame, you can see the last column is cluster with value 1, 2, 3, 4. What does it mean? It means that for each observation here, for each customer here, they will belong to one cluster. For instance, customer 1 right here, they belong to cluster 1, right? Customer 12, let's see. They also belong to cluster 1. Customer 13, they belong to cluster 4, right? Great. So we already finishing the clustering analysis. But as I mentioned to you a few times, running the code could be manageable. Learning the software is manageable, but to describe the cluster, to illustrate the picture of the customer quite challenging. And to do this description step, we need to know some characteristic from the cluster data. First of all, we need to calculate the segment size. And to calculate the segment size, we need to take the number of the observation from each cluster and divide it by the total number of rows. And the total number of rows is, we know that's 2,300. You can put it here, 2,300, or you can do it another way. You can tell the program to take the total number of rows of your final data set, right? Your final data set is df final. All right, let's run the code. Great. Now you need to take that number times 100 so you will get the percentage and store that data in the percentage variable. Right. Now let's show the segment size in percentage. Do you think what we should put it here in this blank? Remember, we just store the percentage values in the percentage variable. So basically we need to print the percentage. variable, right? Look, we have four variable, 1, 2, 3, 4, and cluster 1 account for 49% of the market, cluster 2, 22%, cluster 3, 12%, cluster 4, 17%. All right here, you will use this function to summarize the mean of each column in the final data set by cluster. Okay, so let's run the code. And we can see the mean for each cluster. Right here, we store the mean of each cluster for each column in the object called segments. So let's run the next code and we will see. Okay, right here we have several columns. So the first column is show us which cluster, okay, that means belongs to. All right, right here, the next column is the time mean. If you check the data description, you will know this column is about the average time that the customer spent at the company booths, right? So in cluster 1, the average time that customers spend is around 12 minutes. For customer from cluster 2, they probably spend 36 minutes. For customer from cluster 3, customer will spend 45 minutes. And customer from cluster 4, customer will spend around 6 minutes. All right. To make it, a little bit easier for our additional analysis, we can store the result in an Excel file. In particular, we can use the function dry XLSX. Okay, right here, what do you think we should put here? We should put the variable segments, right? All right, great. Now we run the last code. Okay, and now you already have the new Excel file called segments.xlsx, okay? You can go to your working directory to open the Excel file. You just save, or you can check the file tab here and you will see, okay? Let me check what is my current working directory. So let's see. Okay, my current working directory is my download folder. And if I go to the download folder, and I can see the news files, the segments, Excel file. And yeah, please open this Excel file. All right, so now you have the Excel file. I think it's much better that you can reduce the number of decimal places. Okay, it's look very nice now. So right now you already have all the means for each variable by cluster. Okay, cluster 1, cluster 2, cluster 3, and cluster 4. Your job doesn't end here. You need to interpret what does each mean value here to you. And that is the end of this video. So in this video, you already know how to run cluster analysis. You know how to draw the dendrogram. You know how to choose optimal number of cluster. And you also know how to describe the characteristic of each cluster or each segment.